Welcome back, everyone. This is the second part of the video series for Chapter 6, and we're studying the School of Behaviorism. Remember, these are the psychologists who don't want to study the mind. They only want to study observable behaviors because they were hardline empiricists. They only believed that you could prove something existed if you only could experience it through your senses, so taste, touch, smell, sight. Those sort of things, and you can't see the mind, so it's not really not really able to investigate the mind scientifically, at least according to their perspective. Now, for the behaviorists, remember they have a series of learning processes that they believe are able to explain pretty much any set of human behaviors you can think of. Now, we talked about habituation first, and this video deals with a process called classical conditioning. So let's take a look at. Now, classical conditioning is a great way to explain how automatic nervous system responses get attached to otherwise completely neutral objects or events in the environment. And what you're essentially doing here is you're pairing one stimulus with another. Now, let me just give you a quick example of this. Let's say that I really enjoy going out to camp. And while I'm camping, I'm going to breathe in the fresh, clean air, and I feel really happy. I feel a lot of joy, and I notice that I can smell pine needles because I'm around pine trees. So what happens is, because I feel really happy because I'm out enjoying nature, and enjoying the experience of camping and hiking and kind of going out and enjoying myself in the wild, what happens is the smell of pine needles, kind of a pine scent, gets paired with that feeling of happiness. Now, the pine needles and the smell, that they don't cause my feeling of happiness at all. It's the actual experience of going camping that makes me feel happy. But what my nervous system learns is that the pine scent becomes a trigger or a kind of a cue or a warning sign that I'm about to go out camping. In other words, the pine smell becomes paired with the process of camping. And in addition to that, so does the feeling of happiness that comes from going camping. Now again, the pine needles themselves have not made me feel happy. There's nothing really about pine needles that makes me excited at all whatsoever, but their smell is so strongly associated with pleasant camping experiences. When I smell pine needles, it makes me feel happy, even if I'm not camping. You see, this is how classical conditioning works. You, as an organism, learn to connect two otherwise unassociated stimuli. Now, the one stimulus, this is just the pine scent, comes to elicit the response, which is the feeling happy, that originally was only caused or elicited by the stimulus of camping. Essentially, the pine scent steals an emotional response or a nervous system response or an automatic response that originally belonged to something else. And this happens all the time. This is the way that you acquire phobias. Now, let me say, let me take somebody, for instance, who is afraid of spiders, just as an example. Now, just seeing a spider is enough to get someone who has strong arachnophobia to really panic and freak out. But most of the time, what originally started this fear is not just the sight of the spider by itself, but let's say the person wakes up and a spider is really, 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 really close to their face. So they'll wake up and suddenly the sight of a spider right in front of you, and this is going to work for anybody, is going to freak the person out. So waking up and being surprised originally creates a state of anxiety. But because the spider is present there, even though you may not be afraid of spiders before, the sight of the spider is paired with the feeling of surprise and anxiousness. And as a result, the next time you see a spider, you begin to feel scared or nervous. Or let's say you have a person who is terrified of dogs. There's nothing about a dog that's going to elicit fear. But let's say this person was bitten by a dog when they're younger. Now, getting bitten by something causes pain. So that's the initial stimulus. But because it was a dog that did the biting, the presence of a dog gets connected with their memory of being bitten. So what happens then is the next time they see a dog, they remember what it was like to be bitten, kind of on an implicit or intuitive level. They're not even necessarily consciously thinking of this. Their nervous system is, though. And the nervous system automatically connects the presence of a dog with the intense fear of being bitten. Now, it's getting bit that makes the person afraid, not the dog at first. But because they were bitten by the dog, which was neutral formerly, gets connected with that fear. Now, if this sounds kind of crazy and confusing at first, don't worry, you're in a kind of a normal place. Every time someone learns about classical conditioning for the first time, it's going to be kind of murky and hard to understand. That's why I've got some additional information and some examples that I'm going to go through to kind of pair this out. If you wanted to summarize how classical conditioning works just on a basic level, what it does is it alerts an organism to a specific stimulus that signals the impending arrival of an important event. So in other words, a neutral stimulus, or originally a neutral stimulus that has nothing to do with any kind of response at all, gets paired or connected with some kind of important event in such a powerful way that that stimulus by itself, even though it didn't used to do anything to you, now elicits very powerful automatic nervous system. This was originally discovered by a man named Ivan Pavlov. And he is the one who originally discovered this through a series of experiments he was running on a group of dogs. Now, Pavlov is not a psychologist. He was originally a physiologist who did his work in Russia. And he won the Nobel Prize in 1904 for his studies on the digestive enzyme processes that work in the stomach of dogs. So he really kind of contributed to our knowledge of how digestion works in a really important way, enough to merit winning a scientific Nobel Prize. Now, as he was doing research on his dogs, he needed to find ways to produce saliva so he could collect the digestive enzymes that are present inside the dog's saliva. And one of the ways that he did this was by ringing a bell just to kind of get the dog's attention. So the dog would sort of look towards Pavlov, and then he would spray a powderized meat substance into the dog's mouth. Now, the whole point of the bell was to just get the dog to look in a specific direction so they would be facing towards the nozzle as it shot meat powder into their mouths. And as the dogs would try to chew on this powderized meat substance, it would produce a lot of saliva, and Pavlov would then go and collect that saliva and use that in his enzyme research. Now, as he was doing this and collecting these basically vials of dog saliva, he began to notice something really weird. When he rang the bell, the dog drooled. And he hadn't even presented food yet. No food was present at all, but the sound of the bell was enough to get the dogs to salivate. And this only happened after he had been running this kind of study for a really long time. What he believed was going on is it wasn't anything about the tone of the bell itself. The dogs weren't just salivating because of the sound, but it's because he paired the sound with food. That produced salivation. You see, the dogs were drooling because they've basically heard their dinner bell. And their nervous system was responding automatically to it. Because it had learned, hey, whenever this bell sound happens, we get food. We need to get ready for the food, so let's start creating saliva that we can use to chew on the food. Even though the food itself is not present, the sound of the bell was enough to get the dogs to drool. This is the moment when we discovered classical conditioning. Let's unpack exactly what he did. How does this happen? How does a bell make dogs drool? How does just looking at a spider make someone feel anxious? How does someone who nearly drowned years ago feel so terrified just at the sight of water? It begins in what we call an acquisition phase. Now, this is the period where you actually learn this brand new response. Now, the tone by itself, this ringing the bell, and you haven't given the poor dogs any meat powder just yet. no response is going to happen. You ring the bell, and they're going to look at you and go, "Why are you ringing that bell at me? I'm a dog. Give me food." At this point, no nervous system response has happened, and we call a stimulus at this point a neutral stimulus. Now, let me be really clear here. Anything can work as a neutral stimulus. You can pair it and create a classically conditioned response with just about anything, as long as you pick the right nervous system response. Now, in this example, we're sticking with the bell, but I'm going to tell you some examples of some other more bizarre instances of classical conditioning here in just a bit. Now, remember, the dog hasn't learned that the bell is connected with food at all. The bell is just a way to get the dog's attention. So the food by itself, when you just give the dogs the meat powder for the very first time, it's going to produce a natural nervous system response, which is salivation. I mean, this is something that we just do normally. We salivate when we see food or we're chewing on food because we need to do this to help us digest the process. It's an automatic response. We don't have any control over it. It's just something that the nervous system normally does. Now, because the food produces this automatic nervous system response, we call it the unconditioned stimulus. And we abbreviate this and we represent this as the UCS. The unconditioned stimulus is whatever stimulus naturally produces this nervous system response that we're interested in. Now, there's really only a handful of things that actually do this. I mean, there's only a handful of these nervous system responses. So this is, again, just that stimulus that elicits this reflexive or innate unconditioned response. Now, the salivation itself, the nervous system response, because it's automatic, and you are supposed to salivate when you see food. You're supposed to feel afraid when you see something that's threatening. You're supposed to have a defensive fear reaction when you experience pain, because you experience sexual arousal when you see an arousing, sexually explicit image. Those are all reflexive nervous system responses, and because of that, we call them the unconditioned response, because you haven't had to do any conditioning to get it. So at the beginning, the bell isn't doing anything yet. The food by itself, which is the unconditioned stimulus, naturally and reflexively produces the response of salivation, and that is the unconditioned response. You don't need any prior learning to have an unconditioned response to an unconditioned stimulus. That's why we say they are unconditioned, because no learning has taken place yet. Now, during the acquisition phase, you begin to ring the bell as you show the dogs the food, which is the unconditioned stimulus, and then you see the unconditioned response, which is the salivation. And you keep pairing these together over and over and over again. Now, eventually, the pairing of the neutral stimulus with the unconditioned stimulus and the unconditioned response is going to begin to change the way you respond to the neutral stimulus. One final note. The unconditioned response is, again, I cannot emphasize this enough, it is reflexive. It is something that the nervous system just naturally does and is elicited by the unconditioned stimulus with zero prior learning. I cannot emphasize that enough. If you're still confused, replay this again and take a look at some of the examples in the textbook on this. I'm going to move forward now and begin to unpack this process. In the case of the dogs, here's what we've done so far. We've rung the tone, and the dog's just like, huh, what? The dog doesn't care, because it's just a tone at this point. The dog hasn't learned anything about the tone. And when you just show the food to the dog begins to salivate. It's unconditioned stimulus. The food just by itself reflexively creates an unconditioned response of salivation. That's all we've done so far. Now, when you get into the acquisition phase, that's when you begin to pair the tone with the food, and then stuff gets... During these learning trials, where the tone and the food keep getting paired repeatedly during this acquisition phase. Now, acquisition just means the process that establishes or strengthens a conditioned response. So what we're doing is we're beginning to connect the tone with the presence of the food and the salivation response that comes afterwards. Pretty soon, as we consistently ring the bell and give the dog food, and the dog salivates. We ring the bell, we give the dog food, the dog salivates. We keep doing that over and over again until one day we ring the bell, we haven't even shown the dog the food yet, and the dog begins to drool. When that has happened, we have moved beyond the acquisition phase into a full-blown classically conditioned response. So, here's what it looks like during conditioning, and also kind of the preconditioning stuff too on top of this. I'm just adding this additional slide or this additional section here. We're pairing the tone, which was the neutral stimulus at first, but is slowly turning into what we call the CS, or the conditioned stimulus. Now we're pairing that with the food powder. Now the reason the dogs drool at first is because they see the powdered meat and they're hungry for it. But eventually, when you ring the tone by itself or ring the bell by itself and the dog drools in the absence of the food, that means you have changed the tone from a neutral stimulus to a conditioned stimulus. When you ring the tone, or ring the bell, and the dog drools, congratulations, you now have a true conditioned stimulus. We abbreviate that as CS. This is a stimulus that, through its association with the unconditioned stimulus, it comes to elicit or produce what looks like what looks like the original reflexive response. We now call this the conditioned response, and it looks exactly like the unconditioned response originally, because what's happening is you ring the bell and the dog is drooling to the sound of the bell, not the presence of the food. The reason we now call this the conditioned response is because the dog is drooling in the absence of any delicious meat powder. The salivation at this point has become a conditioned response. It's the same response that you see to the food stimulus, but the big difference here, the reason this is now a conditioned response, is because the dog is drooling to the sound of the bell, not the presence of the food. Really, we just define the conditioned response as the response that has been elicited by the conditioned stimulus. Now, again, notice the unconditioned response and the conditioned response, they're the same. They're both salivation. But what makes them different is they have different triggers. The conditioned response here is salivation to the bell. The unconditioned response is salivation to the food. That is what makes these things different. What triggers the behavior. All right. Here's the whole process laid out in front of you. At first, the tone does nothing. There's no salivating response. And at first, the dog only drools when they see food. Now, the food's the unconditioned stimulus. It just naturally makes dogs drool happily, and that is the unconditioned response. Now, we start to pair that tone or that bell sound with the presentation of the food, and we keep doing this over and over and over again. And you know what? The dog's going to keep drooling. Really, at the beginning, they're drooling because the food is there, but eventually their nervous system starts to learn that they hear this tone before they get the food. Pretty soon, the nervous system starts to anticipate what happens next. The nervous system hears that bell and goes, aha, I know what's going to happen next. We're going to get food. So it starts to salivate to the sound of the tone. Now, the second the tone produces the salivation response, everything has changed. We have now a conditioned stimulus that produces a conditioned response. Again, spend some time going over these last few slides. Play it back, stop it, rewind if any of this is confusing. Take notes as you're going, and take it at your own pace until this starts to make some kind of sense. I'm going to give you some examples here in just a second. Okay, here's a quick activity to help you sort of apply this stuff. Let's say that my friend has a fish tank, and my friend goes to feed the fish. Now at first, this is something that fish do, when you sprinkle food flakes on top of the water to feed fish do this interesting behavior where they frenzy. They kind of go crazy and get really excited that food is on top of the surface of the water, and they rush up as fast as they can to grab the food flakes and eat it. It's kind of a fun thing to watch. So At first, my fish would only frenzy when he actually gave them the food. Now, he had this behavior that he did where he would turn on the light on his fish tank before he opened it up and sprinkled the food flakes across the surface of the water. Now, over time, when he turned on the light, the fish would frenzy, even though they had not been fed anything yet. I want you to pause the video in just a second, and I want you to think about this example. Try to figure out what the unconditioned stimulus is in this situation. Now remember, the unconditioned stimulus is going to be a natural stimulus that creates a reflexive response, and the unconditioned response is that reflexive response only to this natural stimulus. The conditioned stimulus is something that is formally neutral. There's nothing about it that has any survival function or biological function attached to it. But it eventually gets paired with the unconditioned stimulus and begins to trigger a conditioned response. Pause the video right now and try to figure out where these four elements are inside this example. And when you're ready, unpause and I'll let you know what they are. Pause now. Go. Okay, if you paused and then actually wrote down your answers for this, let's go ahead and unpack this one. So, first of all, the unconditioned stimulus on this one is the fish food. Fish naturally need to eat food to survive, so their nervous systems have this natural unconditioned response, which is to frenzy, whenever they have a food source available. And this is just a behavior that permits them to get quick and aggressive access to the food that they need to eat in order to live. So that's pretty straightforward. The conditioned stimulus in this case is the light. Now remember, my friend is turning on the light on his fish tank before he starts to feed his fish every single time. Now pretty soon, the fish's nervous systems get used to that light going on right before food appears. And they learn that the light is a warning signal or an alert that food is about to show up. So the conditioned response then is when the fish frenzy to the light being turned on. Now, if this still doesn't make sense, again, pause the video, play it back, and just kind of go back through the cycle again already just to kind of make sure this all makes sense. Let's try out a couple more examples. I want you to very quickly try and work out your own example. So you're going to need to have all of the following pieces of information in order to have a true classically conditioned behavior. First, your unconditioned stimulus needs to reflexively elicit an unconditioned response. Second, the pairing of the unconditioned stimulus needs to occur so it's connected with the conditioned stimulus. So you need to take something that's previously neutral and keep pairing it with the unconditioned stimulus until it creates our conditioned response. And the conditioned stimulus should elicit the conditioned response in the absence of the original unconditioned stimulus. And remember, the conditioned response is going to be identical to the unconditioned stimulus. Now here's what I would like you guys to do. Why don't you write down your answers, and I'm going to open up a discussion forum on Canvas. And I want you to kind of post what you came up with on this, and I will respond to let you know how close you were to, kind of coming up with a good, accurate example. Now, don't be afraid of getting this wrong. If that's the whole purpose of me giving you this exercise, is so I can give you some direct feedback on how close you're getting to kind of wrapping your mind around this. I'll try to have this active at the same time that this video goes live on Canvas. I'll just make sure that you can find the discussion forum present there. So I really strongly encourage you to take advantage of this. You won't get marked down if you screw the thing up or kind of put the pieces together incorrectly. This is purely so I can help you out and make sure that everything is kind of coming together smoothly with this activity. Okay. If you've had the opportunity to post some things on Canvas related to the classical conditioning exercise that I just gave you, let's go ahead and move on to some important questions about these conditioned stimulus responses and whether or not you can get rid of them. Now, you can eliminate these classically conditioned behaviors once you've acquired them. And this is good news, because some of them can be particularly unpleasant. Now, let me give you a couple examples of some classically conditioned acquired behaviors that we've done in some experiments. There was an experiment that was run a couple years ago, actually quite a long time ago now that I think about it, where a group of researchers were curious about how people develop sexual fetishes. And this is when they sexualize or experience sexual arousal to otherwise inanimate objects or things that people would normally not necessarily find sexually arousing. So one of the things that they did is they decided to take shoes as the neutral stimulus. And again, there's nothing initially sexy or attractive about it, just a pair of shoes. But what they began to do is they decided to pair pictures of shoes with a particularly powerful set of unconditioned stimuli. And in this case, they chose pornographic images. And what they did is they were able to then measure the degree of sexual arousal of men who were observing these images by hooking up something to male genitalia that actually tells them the degree to which they are developing erections. It's a pretty invasive research technique. It's kind of hard to get past an institutional review board nowadays, but this is something that they decided they really wanted to do. So, what they did is they had the participants come in, they hooked them up to this machine to measure the intensity of their erections, and then they began to alternate between images of shoes, which initially produced no erection at all whatsoever because it was a neutral stimulus, and then pornographic images. And that produced an erection when they viewed the pornographic imagery. Now, as they began to randomly show shoes, then pornographic images, then shoes, then porn, then shoes, then porn, eventually they had the participants leave the lab for a little while, then come back in, and then they showed them an image of a shoe just by itself, and that was enough to create an erection. That's it. What they had done is they had classically conditioned a sexual response in these men to shoes. So, if you have that classically conditioned response and you no longer want it, there is some good news. Fortunately, the process can go extinct, or the behavior can go extinct. And this just happens, I'm going back really quickly to the example of Pavlov's dogs. Eventually what Pavlov noticed is if he kept ringing the bell but did not give the dogs meat powder as food, just ringing the bell by itself over time, eventually the dogs stopped salivating to the bell because their nervous system figured out, oh, hey, wait a minute. They're not giving me food anymore. The bell no longer signals the presence of food, so they just lost the connection. And the nervous system sort of lost its response to the bell. With the men in the shoes, you just keep showing them shoes over and over and over and over again over a really, really long period of time, and eventually they would lose the intensity of the sexual response to it. So really what's happening here is this conditioned response is just weakening and eventually disappearing. And again, we call this process extinction. So yes, you can get rid of some classically conditioned behaviors. They just naturally go extinct on their own after a certain amount of time. Some, however, are more persistent and are very resistant to the extinction process. This is especially true of phobias that have been acquired through classical conditioning because they sort of reinforce themselves just with a really high level of autonomic nervous system arousal whenever you see something that is scary. Now, if you're running this through what we call an extinction process, just ringing the tone by itself, each individual time you ring the tone, we call that an extinction trial. Eventually, through a number of extinction trials, the salivation response will weaken and then eventually vanish. Now, you can experience a spontaneous recovery. Let's say that Pavlov hasn't rung the bell for a really, really, really long time in his lab, and what happens when suddenly Pavlov decides to ring this out of nowhere, all of a sudden the dogs just start drooling again. Spontaneous recovery like these, they happen every once in a while. This can happen even if someone's recovered from a phobia, suddenly they have a relapse of their fear response to whatever they were afraid of. In the case of the men who had recovered from their sexual responses to these shoes, suddenly they go into a shoe store and then they experience an intense level of sexual arousal as a result of it, and this is after they had already extincted their prior sexual arousal responses to shoes before. Really, this is just a temporary return of an extinguished response after a delay of time. This typically does happen whenever the extinction process takes place. There's usually some kind of spontaneous recovery, and it can sometimes necessitate the need to go through a series of extinctions. Now let me just sort of show you what this looks like. Let's say that we have the trials here graphed out along the x-axis, that's over on the bottom of the screen, and let's say that we sort of have the intensity of the response to whatever stimulus that you're testing here. As you're acquiring the intensity of the conditioned stimulus, you're acquiring this conditioned response, you see that your intensity or your response to the conditioned stimulus increases its intensity and stays that rate for quite a while. Then we move from that red line over into this blue line where we're just showing the conditioned stimulus by itself. At first, we have a pretty intense response to the conditioned stimulus. Then after a couple trials, it drops off in its intensity because there's nothing there to reinforce that response and keep it strong. And eventually just kind of goes away. Then let's say we go over here to this green line. Let's say you've had a 24-hour rest, and then you have the participant come back in the lab. You show them the shoe again, or you have the dogs and you ring the bell again, and suddenly they have this strong response to it again, but then it tapers off in its intensity because you're just showing the conditioned stimulus alone. Then let's say we have another 24-hour rest and we have a second spontaneous recovery. You present the conditioned stimulus alone, you get a bit of a response from it, but then it weakens and eventually relapses back to a fairly low level of responding to it. Now, two things can happen when you are dealing with a classically conditioned stimulus-response relationship. We get what we call generalization and discrimination. Now, generalization, or stimulus generalization, just means that a stimulus that's similar to that conditioned stimulus can elicit a conditioned response. So let's say you are using a particular bell sound when you're training your dog to salivate. Let's say you go home, you take a break, the dog comes with you, they're taking a rest, and somebody comes up and rings the doorbell. And it's slightly different sound, but it has a pretty similar tone. So instead of ringing to the handbell or the hand tone that you're using, the dog then suddenly starts to salivate to the sound of your doorbell. Or maybe they start to salivate to the sound of a bell that's ringing down the street. If you classically condition a response, kind of a sexual arousal response in males, to shoes, maybe they begin to also manifest this arousal response to boots or other forms of footwear. Now, stimulus generalization just means that this conditioned response is beginning to spread to other things. And to prevent stimulus generalizations from really kind of going wild, organisms have to learn to discriminate between the stimuli. And what this means is your nervous system learns to realize when the stimulus that's presented to it is different and is not supposed to some kind of classically conditioned response. Sorry, I didn't mean for that gap to be there in the audio recording. That's just kind of the way that PowerPoint renders things. So let me say that again. Stimulus discrimination means that your nervous system is able to tell the difference between something that should produce a classically conditioned response and something that should not. And you normally see this when the conditioned response occurs to some stimulation, but not to others. So what I mean by this is maybe the dog salivates to the sound of the doorbell, but maybe the sound of church bells does not produce drooling. Or maybe the dog salivates to the sound of the doorbell and of the handbell that you use, but maybe, let's say you have a ringtone on your cell phone that kind of sounds like bells ringing, and when they hear that go off, they don't salivate either. It's just they are able to tell the difference between those things. Now, ultimately, the dog knows that the church bell isn't quite so tightly paired with the food, that the sound of your phone ringing is not so tightly paired with the presentation of food, and really the reason you respond differently then in that case is because the two stimulations predict very different outcomes. In other words, the doorbell sounds a lot like the food bell, and as a result the dog salivates, but the church bell is too different from the sound of the doorbell, so the dog knows it's not going to signal the presence of food. It's just the sound of a church bell ringing in the distance. The dog does not salivate as a result. Now, there's an actual example I did want to use, for instance. My dogs tend to know the difference between me leashing them up to go on a walk with them versus me leashing them up to take them into the backyard. They can tell kind of a difference in the tone of my voice. So if I'm leashing them up to take them out in the backyard and I say, let's go outside, they know that my tone of voice sounds different, so they run to the back door. And if I say, let's go on a walk, they can recognize there's a difference between those stimuli, so they run to the front door instead and get ready to go on a walk. Now, generalization and discrimination was discovered in a very famous experiment conducted by John Watson. Remember, this is the guy who really sort of kicked off the behaviorist revolution. Watson took an 11-month-old child named Little Albert, excuse me, and scared the living crap out of him with a variety of very, very loud noises to study stimulus generalization. You see, Watson was trying to create a classically conditioned fear in little Albert. Now, originally, Albert was not afraid of white rats. Watson would show a big, fluffy, fuzzy white rat to little Albert, and Albert would reach for it and pet it and play with it, and the rat was pretty docile, and it would let Albert kind of play with it as well. There was no fear at all whatsoever present here. And really, at this point, the rat is just a neutral stimulus. Now, what Watson did is he paired the white rat with an incredibly loud noise. What he did is he hung a steel bar from the ceiling right behind little Albert's head. And Watson would stand there and he would hit the steel bar as hard as he possibly could with a hammer. I don't know if you've heard what a steel bar sounds like when it's been struck by something else metallic. It is incredibly loud. This very loud noise is the unconditioned stimulus, and naturally Albert's terror response and the crying just at the loud sound was the unconditioned response. Now, at this point, Watson was pairing the white rat with this loud noise, so that's the acquisition phase. And he kept repeating this over and over again. Every time Albert reached for the little white rat to play with it, Watson would hit the steel bar. There would be an incredibly loud noise that was painful to Albert. Albert would scream and cry and recoil away in pain. Eventually, all Watson had to do is show little Albert the fuzzy white rat by itself. And eventually, once that happened, Albert would see the white rat and would scream and cry and try to get away from it. Now, at that point, the white rat is the conditioned stimulus, and Albert's fear of the white rat is a conditioned response, because Albert now thinks the white rat is going to cause the incredibly loud, scary noise happening behind him. Now, Albert showed no fear. Once Albert had acquired this fear of the white rat, Watson began to pair the white rat and the loud noise with the presentation of colored blocks, or little blocks that had different colors to them. And when he did this, even though Albert was still showing an intense fear response to the white rat, when just the white rat and the blocks were presented by themselves without the loud noise, for some reason, the loud noise did not generalize to the colored blocks. Albert was able to discriminate between those two. Albert could say, okay, the white rat is the thing that's causing the scary noise, not the colored blocks. Well, he couldn't really say this. He was an 11-month-old infant, but his nervous system could still figure this out. Now, Watson demonstrated some stimulus generalization. What he did is he showed other fuzzy white objects to little Albert, and little Albert had fear reactions to those things as well. Watson would also put on a Santa Claus mask that had a big fuzzy white beard, and the fuzzy white beard was enough to then continue to scare little Albert. Again, at this point, we're not hitting the steel bar at all. We're just showing Albert these other fuzzy white objects, and the fuzziness and the whiteness is enough to remind Albert of the white rat. And this fear response to fuzzy white generalizes from the white rat to other fuzzy white objects. It was Watson's research on this that allowed us to discover this process of stimulus generalization. Here's some images actually from the little Albert experiment. And these are touched up photographs, if I'm remembering correctly from the sources. Now, here's Albert again before conditioning takes place. He sees the white rat. He has no problem with it. He thinks it's awesome. Then Watson hits that steel bar and gets Albert to have this fear reaction to the little white rat. And over on the bottom right, again, this is an actual, again, I think this is a doctored photograph. They just cleaned up some of the lines a little bit and filled in some stuff. But this is a picture of John Watson coming after little Albert wearing a Santa Claus mask. And you can see that Albert is crawling away in abject terror, trying to escape the evil John Watson. Now, the hand and leg, obviously that's a person sitting behind Albert's shoulder there. That is John Watson's graduate student. Her name is Rosalie Rayner. Watson was having an affair with her, a rather torrid one at this point in time. While they were running this experiment, it would eventually go on to destroy John Watson's career and force him to leave academics in shame. He would then go on to marry Rosalie Rayner and write parenting books. As you can gather here, based on what he's doing to this kid, John Watson's parenting advice wasn't exactly. Now here's a shot of how they set things up, with Watson sitting there smirking like some kind of gigantic asshole, and with the hammer smacking the steel bar, and there's a picture of Rosalie Rayner introducing the white rat, and poor little Albert about to be terrified out of his mind. Now, classical conditioning is not just all stimulus generalization and affairs with female graduate students and people's careers getting ruined and wearing Santa Claus masks, scaring small children, and generalization and all this other stuff. There's more to it than just that. We also have some additional effects that can take place if you're experiencing a classically conditioned response. And I kind of mentioned one of them a second ago when I was describing the little Albert experiment. So you start out by pairing the white rat with the really loud, scary noise. And once you take away the loud, scary noise, little Albert's scared just to see the white rat. Well, Watson went back and then introduced colored blocks to the situation, where he showed the white rat and colored blocks at the same time. And remember, little Albert's already been taught to fear the white rat. Watson then starts to make this really loud, crashing noise again with that steel bar. Now, what Watson was hoping to do was kind of show that you can that the fear would then spread to the colored blocks if you introduce the sound of this loud crashing noise in addition to this white rat. What happened, though, you took away the loud noise, and again, you've been making this really painful loud noise while the rat and the blocks are both clearly visible. But what happened was that little Albert showed no fear response to the colored blocks. He only stayed afraid of the white rat. This is a blocking effect. So what this means is a previously established association to one stimulus blocks the formation of an association to an added stimulus. So that means because little Albert had already, his nervous system had already paired the white rat with the fear response to the gigantic crashing noise made by the steel bar, that's as far as that connection was going to go. Adding the colored blocks did not matter. Making that loud crashing noise was only going to signal a fear. The presence of the white rat, I apologize, let me say that again. The white rat alone will only signal the loud crashing sound. The colored blocks, even though they were there, the white rat had already been paired with the loud noise. The colored blocks do not develop a new association between those two things. Now, we've done this in a couple ways with animal experiments. What we do is we take an animal and we place it in a cage with a light and a buzzer, and we electrify the floor. And this is a grid setup called a Skinner box, and I'll show you a picture of this in a little while. Actually, probably in video 3 I'll show you a picture of what this looks like. So what we do is we want to kind of train the rat that's inside the Skinner box to be afraid of the light. So we turn on the light just before we administer a very mild, surprising electric shock to the rat's feet. The rat squeaks and it jumps and it runs to the corner of the box to try to get away from whatever caused the electric shock. So we keep doing this until just showing the light to the rat makes the rat run away in fear. So once we've done this and the rat's already afraid of the light, we then begin to do something different. We turn on the light, but we also add a nice little dinging sound. And when we do this, the light goes on, the tone sounds, and the rat gets another shock. We go into a brand new acquisition phase. And we keep doing this over and over and over again, and we hope that the rat will be afraid of both the light and the tone. But what happens once we've done this, we've paired the light and the tone with the electric shock, we take away the shock and we turn on the light, and the rat shows the fear response again. Then we turn off the light and we wait a little bit and we play the tone. The rat does not show any fear to the tone, but shows plenty of fear to the light. Now, we wanted to double check ourselves on this. So the experimenters who ran this study decided, okay, wait, hold on. Maybe there's something just about the fact that it's a sound that's keeping the rats from getting afraid. So let's try this. So they started out with just the tone, with a new set of rats, totally new set of rats. We play the tone for the rats and then administer a little electric shock. And we do this until playing the tone makes the rat afraid of getting an electric shock. So we just play the little tone, and then the rat, in the absence of the shock, runs into the corner of its cage in fear. Then we go back again, and we turn on the light and play the tone and give the rat a shock all at the same time, again hoping that we'll be able to get the rat to be afraid of the light and the tone. Well, what happens then is because the tone was first connected to the fear of the shock, the rat is afraid of the tone, but not afraid of the light. So what we learned then is, for whatever condition response you might have, what it gets stuck to first is the thing it's gonna stay stuck to. If you learn to associate the light with an electric shock, then the light's the only thing that's gonna scare you. If you learn to associate the tone with the electric shock, then the tone is the only thing that's gonna scare you. If you associate the presence of a white rat with a loud sound, the white rat is the only thing that's going to scare you, and other things that look like the white rat. Okay, if this doesn't make any sense, again, play this back, or you can always send me questions. I want to talk with you very quickly about some special kinds of classically conditioned behaviors. One is called a taste aversion. This is a very, very powerful classically conditioned response. And it results from pairing a conditioned stimulus, which is usually the taste of a specific food, with an unconditioned stimulus. Sorry, I abbreviated unconditioned stimulus as US here. It should be UCS. That's a typo on my part. Sorry. Now, with this, the unconditioned stimulus is the feeling of being, is really whatever causes you to be sick. So maybe we administer a drug that creates nausea, or we administer a very low dose of radiation that causes nausea inside a person's system. Now, what we do from there then, okay, so what we do then is we take a look at the unconditioned response that comes from the presence of the drug or the radiation, which is usually feeling sick. Now, taste aversion is so powerful, you only need a single trial of it in order to experience it. And really, the administration of a drug or the presence of radiation, we do that just to simulate normal things like viruses or infections or food poisoning or things that make people feel nauseous or sick. I've experienced a taste aversion before. It's extremely unpleasant. When I was a freshman in college, I went to a coffee house with a friend of mine. Went downstairs and they had a table set up down there, kind of like a buffet line sort of a thing, and it just had a bunch of free bagels, cream cheese, and apple cider. So I was like, hey, it's free food, and I'm hungry, so I grabbed something to eat, and as I was kind of eating it, and I spread some cream cheese on a cinnamon, I think it was a cinnamon bagel, and I drank the apple cider that also had a pretty powerful cinnamon flavor to it. And I learned that night that you really should, free food is great, but free food in sort of a questionable-looking coffee house when the food is kind of laid out in a questionable manner for a questionable amount of time, and you're spreading questionable dairy products on the questionable food, probably a bad idea, because I went home and I spent the rest of the night throwing up into the toilet. Now, what happened there is I experienced an unconditioned stimulus, which is food poisoning, and the unconditioned response of throwing up all of my organs and stomach contents uncontrollably for hours into the toilet. It was deeply miserable. Now, I thought nothing of it, and I got up after the next morning, went down to breakfast. I felt a lot better, felt like everything was out of my system, and I was really hungry. I was like, I'm going to go get a bagel. So I go up and I reach for a cinnamon bagel, and I smell it. I smell the cinnamon smell, and I feel sick all over again. And oh my gosh, it was terrible. I felt miserable again, and I walked away from the cinnamon bagel. I got the smell out of my system, and I felt a lot better. So I was like, okay, what the heck was that? As it turns out, I had developed a classically conditioned taste aversion to cinnamon bagels. Now, the conditioned stimulus in that case is the smell and the taste of the cinnamon bagel, and my conditioned response was a powerful feeling I was going to throw up all of my organs and all of my stomach content again into the toilet. Now, what happened here is my nervous system was trying to do me a favor. We believe that we have evolved taste aversion to protect ourselves from eating poison food. Or food that could be toxic. So you eat something, it makes you sick, you throw up. The next time you come into contact with that food, you will feel ill, and you will avoid it as a result. Now, this can occur as long delay learning. Most of the time with these conditioned stimulus, conditioned response associations with the unconditioned stimulus and unconditioned response, that has to happen within a pretty tight window of time. Usually almost immediately after. But with taste aversion, no. This can happen for a very, very long period of time after the original exposure to the conditioned stimulus. So it was a couple hours after I had eaten the cinnamon bagel and when I got sick. But for some reason, my nervous system latched on to the cinnamon bagel as the cause of my sickness. And as a result, made me feel gross, icky, and nasty every time I smelled a cinnamon bagel after that. So really, this can take place after several hours. Maybe you've had this happen to you. You eat something and you get really sick, and then you get sick a couple hours later, and you're throwing up, and then you think of one specific food item that you believe caused this. Then when you think about that thing, the next time you feel sick to your stomach. Again, we believe we evolved this ability to help keep us from eating poisonous or rotten food. Now, just so you are aware, in case you decide to play a prank on Dr. Mattson, thinking it'd be funny if you took some cinnamon bagels and hide them around a classroom, and I'm mentioning this because colleagues who have been honest with their classes about classically conditioned responses to things before have been then pranked by their classes by releasing that thing into the environment, which could include, I don't know, hiding cinnamon bagels around the podium to see if you could make Dr. Mattson sick. Just so you are aware, when I realized I was going to become a professor and realized the dangers of using this story as an example, I put my mind to it and wiped out the classically conditioned behavior by exposing myself to the cinnamon-flavored bagels again and again and again until I was no longer nauseous to them. So you can overcome these taste aversions, but they are really, really powerful, and it took me a really long time to overcome this one. We're talking years. Now, we've studied taste aversion in a lab setting to kind of understand how it works, and there's a very famous study called the Sweetwater Study that tested this with rats. It was run by two guys named Smith and Roll in 1967. Now, what they did is they took two groups of rats and they deprived them of water. Now, one of the groups is going to be the test group, the other one's going to be the control group on some form. But in order to get the rats to do the behavior they needed them to do, they had to kind of get them thirsty. So they didn't give them water for a while. And then they released the rats into a cage where they were allowed to drink a sugar sweet water solution. Now, rats love things that taste sweet. Most mammals love things that taste sweet. It's just kind of the way that our brains are wired. We just really love sweet-tasting things. Now, the test group was exposed to a very mild dose of radiation at various intervals after they drank from the sweetened water. The other group was not. They were not exposed to anything. They were just allowed to drink the sweet water just fine. Then we took those two rats and observed their behavior afterwards, and what we did then is took the rats, deprived them again of water for a little bit, and then put them back into a cage. And what we did then is we gave them a choice. They could drink from a normal bowl of water with unsweetened water, and then a second bowl that contained sweetened water. Now you can probably imagine what happened here. The rats that were exposed to the radiation felt sick after drinking the sweet water, so what they would do is they would run up to the sweet water solution, taste it once, and kind of wince, and then they would go spend the rest of their time drinking from the normal water solution. The rats that were not exposed to the radiation spent all their time chugging the sweet, sugary water. So that was just, again, a lab demonstration of this taste aversion principle. Here again, this is just a demonstration, sorry, not a demonstration. This is just a documentation of the results. The rats that were, this is just going to repeat a lot of what I just said, but let me just go through it anyway. Rats exposed to the radiation avoided the sweet water when they were given the choice. And what they discovered by varying the time or the interval between drinking the sweet water and exposing the rats to radiation, it could impact the intensity of their avoidance of that sweet water. So the magnitude of avoidance was directly related to the conditioned stimulus, unconditioned stimulus interval. The sooner they received the radiation after drinking, the more they would avoid that water later on. So shorter intervals of radiation, or shorter intervals between drinking and receiving the radiation meant more avoidance, and longer intervals meant... So what does this taste aversion give us? The result in general in nature. Why would we evolve a process like this? How does evolution use this? Well, there are taste aversions present in nature, like this poor blue jay here eating this monarch butterfly. Monarch butterflies are kind of coated in a substance on their wing that make them extremely disgusting for birds to eat them, and they actually make birds sick. So even though a single monarch butterfly gets eaten by a bird and it dies, the bird that eats the monarch butterfly gets sick and as a result has an aversion to eating other monarch butterflies, and that actually ends up protecting the species, because any bird that's dumb enough to try to eat one of them ends up getting sick as a result. They're not sick enough to kill them, but sick enough to make them vomit. And this results in that bird then avoiding any monarch butterflies at all whatsoever. So really, this is just a simple conditioned response to food. We pair the food that we ate with getting ill, and what this then does, what this results in then is the sight or the smell of the food just making us sick or disgusting us to the point where we refuse to get close to it and eat it. And that's all I have to say about classical conditioning. It's a very powerful process, and the most important thing to remember about it, remember these are automatic reflexive responses that get connected with really anything in the environment at all whatsoever. There's an example that I want to give you very quickly to illustrate how arbitrary this process can be. I spent a little time studying abroad in England, and while I was there during the evenings, my roommate and I would watch British television because it's pretty entertaining and bizarre compared to United States television. It's actually a lot more interesting. Well, they had a game show on that involved people facing different things that terrified them, and one member of the audience was called out to come down and participate kind of against his will. As it turns out, his sisters knew that he was going to go watch the show, so they informed the host of the show and the producers that he had a very deep fear of oranges. Yes, the fruit, oranges. As it turns out, he grew up with these 4 older sisters in an orange grove. And one day, while he was out working in the grove, his 4 older sisters ambushed him and started throwing unripened oranges at him. Now, I don't know if you've ever seen or held an orange that was not ripe yet, but it feels like a softball. And they are extremely hard, and they pelted this poor kid with them and actually injured him pretty badly. So he grows up, and as it turns out, the experience was intense enough that he developed a phobia of oranges. So in that case, the unconditioned stimulus was getting pelted by oranges. The unconditioned response was the pain and anguish and agony of being pelted by underripe oranges. The conditioned stimulus in the case was the sight or smell of oranges, and the conditioned response was this overwhelming fear of oranges. Now, this guy was called down, and he was visibly nervous when they began to talk with him about how he had grown up in an orange grove. So what they did is they told him, well, if you're really terrified of oranges, huh? And he said, yes, I'm deathly afraid of them. And he was beginning to lose color in his face as he's saying this. So they said, well, we will give you 10,000 pounds if you can touch an orange. So they wheel out this glass case filled with oranges. And they tell him if he can get inside and just touch one, then he wins a bunch of money. And he nearly walks off the stage right there, and they had to stop him from going, even though it was a really simple thing to earn a lot of money fairly quickly. They still had to do a lot of coaxing and convincing. So the way that they had this case set up is there was sort of this corridor connected to it. He had to open a door and walk down it, then open a second door, which was the room filled with the oranges. And there was a person standing inside this case holding a basket of oranges, and he just had to touch one, and that was it. So he opens the door and he gets into the hallway leading to the room with the oranges in it, and he sort of presses himself up against the wall the second he can smell the oranges, and he starts to sweat and starts to panic. And the host has to really kind of coax him a bit more. Eventually he slowly and very reluctantly walks up and touches the doorknob, and then kind of cringes away again. And after more cajoling and taunting and encouragement from the audience, he opens this door. He quickly touches one orange with the tip of his finger, and the second he does, he panics and he runs out of that room as fast as he possibly can. He then stands there as the host is congratulating him with a panicked look on his face, and he holds out the hand that had touched the orange away from the rest of his body, almost as if he had dipped it in raw sewage. He doesn't care at all about the fact that he has won a ton of money. He only wants to go find a place where he can wash the orange smell off of his hand. This is an intense phobia to oranges. That's how powerful these associations can be if the unconditioned stimulus and the unconditioned response are particularly intense and traumatic. What he essentially experienced was a symptom of what we probably would call post-traumatic stress disorder, especially in his case, which can involve very powerful, classically conditioned fears of specific traumatic events or memories connected to that traumatic event. Now, we'll get into post-traumatic stress disorder at the end of the quarter, but for now, be aware that this is one of the mechanisms that can play a role in this disorder. We'll also talk about phobias a little bit later and ways to remove them, usually through extinction trials. But for now, that's it for classical conditioning. If you have any questions about this, don't hesitate to contact me through Canvas or send me an email. I know this can be a little bit tricky, and just as a fair warning, most of the time the second exam is when I tend to see the biggest drop in scores, and it's usually because of the difficulty students have with material connected to classical conditioning. So really work on this stuff. Don't just assume that my second exam is going to get easier. It actually is a little bit more difficult because of this material. Really spend a lot of time focusing on classical conditioning to try and understand it. That's all for classical conditioning. Let's move on now to operant conditioning and video.